The last type of problem I want to talk about in this first unit is actually goes back to mass percent. And we talked about what mass percent is, and actually we did something in the lab. Remember, we had the egg and came up with the weight percent of shell, weight percent of white, weight percent of yolk. But if somebody gives you a percent, you need to be able to unpack it. And we talked a little bit about that. And if you unpack it, then you'll get, oh, say X grams of, well, let's just do it this way. Let's say somebody has a salt solution and it is 75, no, that's, wow, 7.5% sodium chloride, NaCl. Because I'm like 75 grams per 100, that won't, okay. So 7.5%, what does that mean? It means that there are 7.5 grams of NaCl in 100 grams of the mixture, in this case the solution. Okay, so now that's kind of a physical property of that solution. So if you look at the units, you can kind of see what you can go back and forth between. You can go from grams of NaCl to grams of solution, or you can go from grams of solution to grams of NaCl. Okay, so the units of your property can tell you what you can use it as a conversion factor for. So let's go ahead and work a problem. So that's funny. I must have seen this before. I came up with my 7.5% NaCl. So this is 7.2%, and it's not NaCl solution in water, NaCl in water, but it's sucrose or sugar in water. And so we have a couple of problems down here. Now again, just like with the density, I think you really need to unpack weight percent. And I'm going to do it on the next slide, but let's just do it right quick here. That 7.2% sucrose means that in 100 grams of solution, there will be 7.2 grams of sucrose. Okay, so we can use this to work problems. So the first problem, notice it's how many grams of sucrose, so question mark grams of sucrose, are there in 65 grams of solution. So can you see where actually if we make this our first term and this our middle term, we can knock it out, okay? The second one then, we're going to use that weight percent as a conversion factor. It says what is the mass, what mass of solution? So question mark grams solution contains 3.3 grams of sucrose. And do you see where actually if we make this our first term, and what if we flip this one, our grams of sucrose will cancel, we're left with grams of solution. So I'm just kind of giving you insight into what we're going to do. So it looks like this. Okay. So again, I should never see the 7.2% in a problem as you're working it. It should always be unpacked into like one of these kind of explanation of what 7.2% sucrose by weight means. Okay. Now notice that how this is kind of the unpacking straight. These are related by flipping. Okay, this one and this one, they're the same thing. It's just we're flipping it. This is kind of the flattened out version of that property of that solution. So, so here's my little hint. Make sure that you have grams of two things. You have grams of sucrose in the numerator for this problem and grams of solution in the denominator. So you just can't leave it grams. You have to be what we call explicit. All right, so let's go ahead and work these, shall we? So for the first one, we're going from grams of solution. We're going to put 65 grams of solution over 1. Since we want units of grams of solution to cancel, be left with units of grams of sucrose. We're going to use the unflipped version of the weight percent of sucrose. Does that make sense? Okay, it's all about making sure our units cancel. Grams of solution cancel with grams of sucrose. That's perfect. Let's see how we need to round this. Is there uncertainty brought by this term? Yes, the term we want to convert. There are 2 sig figs there. Is there uncertainty brought by this term? Yes. Actually, there's uncertainty brought by the 7.2. There's 2 sig figs there. And this 100, actually, there's no uncertainty brought by that. That's by definition. So we have 2 sig figs there. So our answer of grams of sucrose rounded to two significant figures, I got 4.7 grams of sucrose. So let's take a look at the second problem. In the second problem, we had grams of sucrose, we wanted grams of solution. So we're going to take the thing we want to convert, which is that 3.3 grams of sucrose, we're going to take that over 1. Now in this case, we want units of grams of sucrose to cancel, and we want to be left with units of grams of solution. This is what the flipped version of the weight percent. So in this case, we're going to have to go 7.2 grams of sucrose versus into 100 grams of solution. So our units of grams of sucrose will cancel. Okay, so it's like the inverse of kind of the weight percent is the way I think of it. So let's see how we're going to round this. Is there uncertainty brought by this term? Yes, there are 2 sig figs. Is there uncertainty brought by this? Yes, again, 2 sig figs. So the answer I got rounded to 2 sig figs is 46 grams of solution. So we bumped up now against our final assignment slide, and it looks like this. And yes, these are in Chapter 13, but yes, you are more than capable of working them.